Aloha! In this video, we're going to be talking about tilt. Tilt is not only very important for power production, but it's also very important when designing your pole mount. So it's good to keep the 45-degree rule in mind. If you think about 5 degrees as a tabletop and 90 degrees as a billboard or wind sail, and you have a tilt higher than 45 degrees with a high wind load, you're having a lot more pressure coming and hitting that wind sail. And on the opposite side, if you have a flatter tilt than 45 degrees and a high snow load, you're having a lot more pressure coming down and sticking to the top of your mount. So I am just going to run this. Let's move it to a 5-degree tilt. And you can always save your file here. What that does is it saves it as a JSON to your computer. That way you always have an option to reload all of this information. And I'm going to go ahead and run this. Keep in mind it is running a lot of calculations and a lot of numbers, especially if it's a larger mount or in a higher wind or snow load area. So do have a little bit of patience with it as it goes through that process. So it looks like it's failing at a standard frame. So it's moving up to an HD frame or heavy duty. And it does look like at this address, which is a park I used to go to when I was a kid. I remember it being very windy and snowy. We're looking at 101 mile per hour winds and 33 pounds per square foot snow. So it is failing at an HD frame. So now it's going up to an XD or extra heavy duty. And it's still at that flat 5-degree tilt. So as you can see, this is failing quite a bit. It's showing you all of these members here. Those are the parts of the structure that are failing. To see those, it's quite easy. You can go up here and show modules, makes it easier to see. And you can go down to this little eyeball here and hit member plate IDs. And now you can see that 1 and 101 are failing. So we have failure of the poles and then failures in several places on the mount as well. So that indicates we do need to flatten up that or steepen up that tip quite a bit. Now you can do that in different increments depending on what you're going to be using the structure for. If it's more of a shade structure or a carport, you do want to keep it as flat as you possibly can. And that might even mean mixing up this configuration. 5 high is obviously going to have quite a bit more pressure on the rails than a 4 high. So those are just some things to think about when you see a failure like this. So for this demonstration, I'm just going to go ahead and move this up to a tilt that is higher than 45 degrees, since it seems like we're having some trouble with that snow load. Oh, and I'm going to save the JSON and refresh, and that's a hard refresh. So you just go ahead and do that. Then you can load your file, grab your JSON, and you can run it from there. And we're going to just run through kind of the same calculations that it did before, only now we're at higher than 45, so that snow should shut off quite well. All right, so it looks like that did really well, passed with a 6-inch pole, standard duty frame. And we're just working on that foundation right now. All right, so we've got a 5.75 foot foundation there. and it passed at 81% utilization for the entire structure. So that's pretty good. All right. So now let's kind of flip the switch here, and let's say we are looking at more of a 90-degree tilt. Let's see how it does against that 101 mile per hour wind speed. I'm going to save my JSON and refresh. And load it up. And we'll run it this way. So again, it's running through all those same calculations, but against more of a wind sail now rather than a tabletop. So we're really testing those wind speeds rather than the snow load right now. So it looks like the frame's passing fine with a standard frame, but the pole is failing, so it's going to a larger pole. And we're going up to an 8-inch 40 now. All right, so it looks like we are passing with an 8-inch pole, standard duty frame, and that's a Schedule 40 pole. Let's just look at the foundation difference, just out of curiosity here. Looks like for a 4x4 square, we're looking at 7.5 feet. So we're definitely getting more pressure on this at that 90-degree angle. The utilization on the frame has actually gone up as well, but it looks like it's in good condition. So that kind of gives you an idea of, how these structures work with different loading pressures, and some easy ways to kind of troubleshoot if you're having an issue getting something to pass. As always, give us a shout if you have any questions. We are here for you, and have a wonderful day. Cheers.